First off, let's open up BloodHound by adding it to the chart, and save it as a new template. Next, let's use the Solver tab to start programming the conditions in. We are going to add the indicator comparison first. Now we are going to change the values. Input A will be using the closing price, and input B will be using the EMA 8. As you can see, the signals are showing already. Notice how the checkboxes are checked. If I uncheck it, the signals will disappear. This is helpful for troubleshooting in the Solver tab. We want the signals to be opposite of what it is showing. So we will change the invert output to true. Next, we will do the same for the 1350 tick chart. Add the indicator comparison. You can move it to the desired place by pushing the up or down buttons. Let's change the values. Change input A to the closing price, and input B to the EMA 18, and then invert the signals. Press F5 to update the changes. As you can see in the confidence, there are shorter ones because it is factoring in signals from two charts. About confidence readings. 1 means BloodHound returned a signal when price reached the target. If the second chart did not return a signal because it hasn't reached its target yet, but the first chart did, then the confidence would be 0.5, half of 1. You can turn the signals off the chart by unchecking the checkboxes, to double-check the signals are correct and troubleshoot that way. We'll use the indicator threshold for the stochastics. We will change the input to the stochastics. Remember to use the K only. We will then add the numbers in the threshold area, 85 and 15. We need to add values to the middle too, because that's just the way it is, so we will use 50 for all of them. You can read more about it in the Shark Indicators documentation. Don't forget to change the long output and short output settings. Let's copy the stochastic node and move it to the 1350 chart. Now we will use the indicator change in slope to satisfy condition 4. You can also use the indicator slope solver, but we will just stick to the other one. Let's change the input to stochastics with using the K line only. Let's uncheck the boxes except the indicator change in slope solver to check if it is giving the proper signals. Remember, you can do this for any solvers. Let's check the stochastics indicator threshold solver to see if the signals are correct also. Before I explain something very important, let's give a unique name to each solver so we don't get confused when we jump from solver to solver. Notice how the signal is given before price reaches the target. It is because BloodHound defaults to 0.8, or 80% close to it. If you do not want that threshold, you can change it to 100% or 1. That way, the signal will be given once price reaches exactly at the value you specified. You do this in the BloodHound indicator itself. You are basically making the signal to become more strict. Now let's make a copy of the slope node for the 1350 tick chart. This was the only part that the original video didn't do, to complete condition 4. Okay, let's now use the indicator comparison for the Bollinger. Change the input A to price. Change the input B to Bollinger. This will be a little confusing. Since we are wanting a short signal when looking at the upper band, and vice versa, we would select short for the upper band and long for the lower band. Now, by default, in the long output section, it is set to give us a long signal when price is greater than the Bollinger. But since we told the Bollinger to give us a short signal, it conflicts, so that's why we need to invert. I know it feels confusing. But the more you do this, the more you will understand it. So we will be making the invert output to true. Let's copy the Bollinger to the 1350 tick chart. Let's check all the boxes to see what signals we get. Since the strategy is not giving us enough signals that we had hoped, we will use the logic board to fine-tune the logic. Remember to create a new logic file. We will need to add all the existing solvers to the board. tip: when you are just working in the solvers tab and stacking the solvers up, it is equivalent to using a ratio node in the logic board. The original video didn't cover much about this node, but it says that it gives the same output as stacking in the solver tab with the checkboxes. The original video didn't explain how to adjust the ratio node, so we would have to find the information somewhere else. By default, all solvers connected to the node will receive an equivalent percentage size that would add up to 100%. So since we have 8 solvers connected to it, each will have 12.5% influence. Since there are still no signals, let's disable some nodes to find which ones are too strict. Since we found that the Bollingers and change in slope node in the 1350 chart is causing a lot of the signals to not appear, we will try the signal extender to see if that helps.